If two resistors are connected in parallel with resistances R1 and R2, then the total resistance R is given by 1 over R equal 1 over R1 plus 1 over R2. If R1 and R2 are increasing at the rates of yada yada and yada yada, respectively, find the rate at which R is changing when yada yada. Okay, so this problem might look scary because you may not be familiar with resistances, but it doesn't matter. They give us enough information in this problem that we can solve it if we use these 4 steps. Step 1, write the rates as derivatives. So the rates in the problem are 0.3 ohms per second, and we're told that's the derivative of R1 with respect to t. We're told that in the problem. R1 is increasing at that rate. Similarly, we're told that derivative with respect of t of R2 is 0.2 ohms per second. And we're asked to find dr dt, the rate at which the total resistance R is changing. Identify the dependent variables in the derivative. Step 2, there are R1, R2, and R. Again, just look at the variable in the numerator. We need an equation relating these. Hey, they give it to us. All right? Step 3, differentiate both sides of that equation from step 2 with respect to t. Okay, now I could use quotient rule, but well, and I could also write this 1 over r is r to the negative 1. Let's just use quotient rule. The bottom times the derivative of the top. Now the derivative of the top is 0, so the bottom times 0 minus the top times the derivative of the bottom over the bottom squared equals, similarly, R1 times 0, the bottom times the derivative of the constant 1, R1 times 0 minus the top times the derivative of the bottom over the bottom squared. Similarly for this last term. Okay, now we can just clean that up a little bit. So this is negative dr dt over r squared equals negative dr1 with respect to t over r1 squared plus a negative, so that's really minus dr2 with respect to t over r2 squared. That's my equation that relates the 3 rates in the problem. Now, substitute values and solve for the unknown derivative. Why don't you try that, and then we'll come back and check it. Don't just skip over this part. Please do this.